And thank you so much to all of the viewers who've joined us from home, members of the media, and to all of the participants, to the Honorable Minister, welcome, the Deputy Minister, Dr. Joe Pasha, welcome, the Director General of Health, Dr. Sandile Buthelezi, a very good welcome to you, and all the MSCs present and senior officials. This is a very important webinar as we look to ensure that we are able to manage the changing situation with our COVID-19 variant here in South Africa. The minister, the deputy minister this evening are joined by a very, very strong team of specialists and in academia and in virology, epidemiology, who are no strangers to any of us. And I'm just going to very quickly introduce our main speakers for the evening. If I could just be given a second. So this evening, we are joined by Professor Shabir Madhi, who is the principal investigator of the AstraZeneca trial. And I would also just like to take this opportunity to congratulate Professor Madhi's recent appointment as the Dean of the Wits School of Medicine. As a UCT alumni myself, congratulations, Professor. We're also very happy to be joined by Professor Glenda Gray, who is the principal investigator for the Johnson & Johnson trial and is, of course, the president of the Medical Research Council. Professor Gray, I see you and welcome. Thank you very much. We really look forward to your inputs. We also have Professor Shub, who is the chair of the MAC on vaccines. And of course, we have Professor Salim Abdul Karim, who is the co-chair of the MAC on COVID-19. We are joined by other experts in the field of genomic surveillance and in the field of epidemiology. And I'm sure when we get to the question and answer session, we may be able to also hear from them. But without much further ado, I would very much like to ask the minister to please open this session for us and explain the purpose of our coming here together this evening. Honorable Minister, over to you.
Thank you very much, Dr. Lwazimanzi. Our esteemed panelists and experts, Professor Salim Abdul Karim, the chairperson of Ministerial Advisory Committee on COVID, and the chairperson, Professor Perry Shub, who is the chairperson of the COVID-19 Vaccines Ministerial Advisory Committee, Professor Glenda Gray, CEO and president of the MRC, and also one of the leading investigators or in the vaccine space, and Professor Shabir Madhi. Also, you have been introduced as the Dean of Science in the Witwatersrand and also a lead scientist on the vaccine area. And of course, Dr. Joe Pasha, Deputy Minister for Health, Dr. Sandile Buthelezi, the Director General, and the MECs who are present here, my colleagues and heads of departments, the health fraternity, academia, fellow South Africans, and members of the media. This evening is an exciting evening where we have indicated in the past that we would always like to ensure that there's transparency in the way we're handling the issues of COVID-19. We've also indicated that we want to make sure that our COVID-19 actions are all linked to the latest available scientific knowledge that we have. And I must say that at this point, for tonight, we want to give a good background in terms of what is going to be a familiar area of dealing with vaccines. Now, South Africa is quite blessed with a huge amount of technical expertise when it comes to scientific research, and particularly in biomedical science and other sciences as well. And so we every now and again have to deal with the fact that quite often there are cutting edge research that gets done and therefore gives us good information, quite leading also compared to some of our peers throughout the whole world. Recently, we actually had our team announcing the sequencing of the genetic sequencing of the COVID-19, indicating the existence of a new variant, which we call 501 V2. And therefore, we had said over the past few weeks that there's a lot of questions that this has raised. And therefore, as the time goes on, we will be sharing new information as we acquire in relation to this particular variant. And at the same time, we have had the good fortune of having our institutions participating in a number of trials in relation to vaccination. And that has given us exciting new information that, firstly, it best compares with what's going on in the whole world, but it also does touch on certain areas of uniqueness of South Africa, which therefore means that whilst we deal with the science in general, we also have to take into account certain of the factors that are affecting a unique environment as South Africans. In this case, therefore, we have tonight a team of our experts who have actually been briefing us and therefore are here today to share with the public the outcomes of the various trials that they've been involved in. The purpose of this discussion is basically twofold: to get the researchers to give us the latest of their research findings, and also look at those issues and highlights the implications to our fight against COVID-19. And secondly, is also to respond to some of the findings from the public health policy point of view, the policy point of view, as to how we're going to be adjusting certain of the plans and programs that we have in place in order to be able to accommodate some of the findings. But it also is clear that new questions have been raised, and therefore we've also directed certain of those questions need to be clarified. Now, we will be aware that recently there's been, we had been waiting, in fact, for this couple of weeks, we're waiting for results to come out in relation to the AstraZeneca trials, as well as the J&J trial. And then, of course, we had already started a program to actually roll out vaccination in the country. And all of this together, we have to now indicate how we're going to be tying it up as we move on. The AstraZeneca trials have been showing, if you look across the world, very good efficacies and also a very strong impact on various aspects of the investigation that was done in terms of the severity of diseases. But of course, you will see today that there might be some areas which we need to do a little bit more work insofar as the area in South Africa is concerned on this vaccine. And Professor Shabir Madhi will take us through all of that, what went onto the trial and what were the findings, and we're going to move from there. Then, of course, Professor Glenda Gray is going to take us through the J&J and also give us what their findings have been. Professor Berishuk is going to then give us comments around the approach to the issues of vaccines and link up with the issues of trial as the team that is actually advising us on the issue of the vaccine. And Professor Abdul Karim will also deal with the issue of vaccines in general, how we should be handling them as a country. I will then come back at the end to indicate that these are the steps that we want to take so that we align all these findings as we move forward. I must say that everything is happening at a very fast pace. And I think from those who are on the research and scientific research side are finding this quite exciting. It's just that, of course, we're dealing with a very difficult challenge of COVID-19, which at this point is slowly coming down in terms of the second peak. And we want to make sure that we start activity on the vaccination side ahead of any other surge returning. And we have said that we're going to focus on the health workers first, and then take the next step, the next batch of South Africans who are at risk. And then, of course, we'll deal with the third phase thereafter. So all of this is on course, but nevertheless, we wanted to appreciate the complexity of the background on the scientific research findings that we have to navigate through and try and conjure together so that we can formulate the best way forward. At this point, therefore, I'd like to bring to the fore Professor Shabir Mahdi, who must then take us through. And Professor is going to go through quite a lot of science, so please be patient with it, because we want you to understand where he comes from, what he has done, and what he has found. And then all of that together is going to be very important for us as we make our way forward. So Professor Shabir Mahdi, please come forward and table your presentation. Thank you very much, Professor.
Good evening, Honorable Minister. Good evening, the Deputy Minister, Director General, and other esteemed guests. And I would like to thank you for extending out this invite for me to be able to share the results of the vaccine trial that has been concluded recently in South Africa, and in particular, the AstraZeneca vaccine trial. But before going ahead, I would like to firstly acknowledge the tremendous participation of South Africans that chose to participate in this particular vaccine trial, as well as many other COVID-19 vaccine trials that are underway. Without your participation, we simply wouldn't be able to appreciate the importance of COVID-19 vaccine, as well as the way these vaccines would work in the country. So once again, to appreciate the involvement of all of the volunteers that raised their hands to take part in this global initiative. And then also to extend my acknowledgement to the many number of other investigators that have been involved in these clinical trials, many of whom unfortunately ended up getting infected during the course of assisting in getting the answers that we require as a country. And finally, the sponsor of the study and the provider of the vaccine, the University of Oxford, as well as funders of the study, which includes the South African Medical Research Council, the Department of Science and Innovation, and the Bill and Melinda Gates Foundation. So what I'm going to do is really take you through the results of the study that was concluded. And these results, in fact, only became available to me during the course of the past week. And over the past week, we've been analyzing the data to get an understanding in terms of exactly what the effect of the AstraZeneca vaccine is in the South African context, and particularly in a context where we faced a resurgence that was a consequence of the emergence of a variant, which we've now come to appreciate is not only more transmissible, but it also might be resistant, both to antibody that has been induced by past infection from earlier virus that was circulating, as well as antibody that might be induced by many of the vaccines. So the study that we conducted on the AstraZeneca vaccine involved enrolling adults between 18 to 65 years of age without HIV and without severe underlying comorbidities. There was a small subset of people with HIV that were included in the study, but I'm not going to report on their results this evening. For the HIV population, we were specifically interested in seeing how well they responded in terms of the immune system to the vaccine. The manner in which these trials are conducted is that when participants volunteer, we randomly allocate them either to receive the vaccine or a placebo substance, which in this particular instance was similar to salt water. And then those individuals will get a repeat dose of the same after about 4 weeks. And the main purpose of the South African study was foremost to establish the safety of the vaccine, and secondly, to see whether the vaccine actually protected against COVID-19, resulting at least 14 days after the second dose of the vaccine. So I do appreciate that we've got a number of members of the public on this call, as well as other people who might not be in the domain of science and research. So one issue that I need to emphasize is that the manner in which we conduct these studies allows you to be able to get a specific understanding at a certain threshold. So if this vaccine, as an example, has got 50%, is 50% effective in protecting against COVID-19, unfortunately, this particular study, which only enrolled about 2,000 participants, would not be able to address the question as to whether the vaccine actually works or not. For us to be able to show success in our study, we need the vaccine to show at least 60% protection against COVID-19. So of the 2,000 participants or volunteers that eventually were enrolled into the study, we were able to analyze roughly about 1,750 of them. 56% of them were male, Importantly, in this study, the median age of participants was roughly about 31 years. The race group demographic was somewhat generalizable to what exists in South Africa, with 68% of individuals being of Black African descent, 14% being white, and 16% identifying as being of mixed race. In this particular study, roughly about 20% of all of the participants were considered to be obese, and 9% were healthcare workers. Now, another important aspect is that the population that we enrolled in the study is a relatively healthy population, in that the prevalence of underlying conditions such as hypertension, diabetes, lung problems, chronic lung problems, were not that highly prevalent, unlike an older population of individuals where these conditions are much more common, and consequently older people would be more at risk of developing severe COVID-19. In our instance, we enrolled a relatively young age group in terms of demographic, with a relatively low prevalence of underlying comorbidities. Hence, the study was not really designed to determine whether the vaccine would protect against severe COVID or not. So what is also important is that when looking at the information that I'm going to present, there's different severities of COVID-19, and perhaps the most important, both from an individual level as well as from a public health perspective, is how well the vaccine works in protecting against the most severe end of the spectrum of disease. And the reason why that's important is obviously is that those who develop severe disease are the ones that unfortunately will end up dying. As I emphasized in the earlier slide, unfortunately, the design of our study, and it being a phase 2 study, was such that the majority of cases that would have occurred in our study would have been mild illness or moderate illness. And this is usually what is largely considered to be more of an upper respiratory tract infection rather than involvement of the lungs. And we also had a very low threshold for investigating individuals. So individuals just needed to have a simple runny nose or nasal congestion or a cough, and we would include the investigation of those individuals to investigate whether or not they might be infected by the virus that causes COVID-19. And the reason I'm emphasizing this different grading is because different studies have reported differently in terms of what exactly they're reporting when it comes to the effectiveness of the vaccine protecting against COVID-19. Generally, one would expect most of the respiratory pathogen vaccines to be much more effective, have a much higher efficacy against severe disease compared to mild or moderate illness. So I would like to take you just through what exactly have transpired in the study to get an understanding in terms of why we're able to address inadvertently two sets of questions. The one being, how well the vaccine works against the virus, which doesn't have the mutations that is prevalent in the virus that's currently dominating in South Africa, and that is now known as a B.1.351 variant. And then also in terms of exactly what happened over the course of time, both for the vaccine effectiveness, as well as in terms of the circulation of different variants. So what you see above in a gray line is the trajectory of the COVID-19 outbreak in South Africa. And the enrollment into this particular study, which is shown over the black line, started at a time when the first wave of the outbreak had peaked. And as we continued enrolling participants into the study, what we observed in South Africa was a fairly rapid decline in terms of the first wave. And at a time when the first wave was very much subsiding and plateauing off, it was only about a quarter of the participants that had already received their second dose of vaccine. And that is important because the design of the study was to determine how well the vaccine worked 14 days after receiving at least the second dose. What subsequently transpired is that the participants continued to be enrolled in the study, and they continued receiving the second dose of vaccine. And as you can see in South Africa, as all of us are pretty aware now, the first wave plateaued off and continued with ongoing virus circulation for roughly about 2 to 2.5 months before we started to observe the resurgence in the Eastern Cape. Upon investigation of the resurgence in the Eastern Cape, what was identified and what has been shared with the public previously was the documentation of a new variant, which was known as a B1351 variant. Now, the reason why this variant is especially important and perhaps more concerning than as an example, the variant that was identified in the United Kingdom a bit earlier, is that this particular variant includes mutations of the genome of the virus, which allows for what is known as a spike protein to differ from what existed previously. And the reason why that is important is that all of the vaccines that have currently been developed have been designed based on the original virus that was circulating. And hence the antibody in a sense, and these antibodies are what is induced by vaccines, that antibody has got a greater affinity for virus that has a spike protein that was coded for by the original virus. Now, with this particular mutation, unfortunately, there are parts of the spike protein where it differs from what existed for the earlier virus. And consequently, the antibody that will be induced by the first generation of vaccines would have a lower affinity for that particular spike protein, means that it might well be less effective, again, in terms of neutralizing the activity of the virus. What you see at the bottom is the different variants that have been circulating. And as I mentioned, from November onwards, what we observed was the evolution of the B1351 variant. And currently in South Africa, more than 90% of all new infections that are occurring are a consequence of the B1351 variant, which we know now to be more transmissible and probably also more virulent than the original virus that was circulating. So after having done a final analysis, we realized that unfortunately we were experiencing a problem when it came to the effectiveness of this vaccine. And consequently, what we decided to do was to analyze the information for how well the vaccine worked, at least until the end of October. And that was before the evolution of the B1351 variant. Now, before sharing with you how well the vaccine worked, another important issue was whether this vaccine is expected to work as well as one would expect it to work, as an example, in the United Kingdom, as well as in Brazil, where the efficacy of the vaccine has been roughly about 70% in those two countries. So when looking at the immune responses of this vaccine, and South Africa is shown in the last column, what we see is that, in fact, the immune responses to this vaccine in South Africa, in terms of the functionality of that antibody, it's similar, if not better, than what was observed in individuals from the United Kingdom as well as in Brazil. So this is a vaccine that stimulates or induces as good an immune response as the vaccine would in other populations in the United Kingdom as well as in Brazil. So what I show you now is information as to how well this vaccine worked, at least until the 31st of October. And what the graph shows you is a cumulative number of cases that have occurred over time. And as you can see, very soon after volunteers started to be infected with the virus, the attack rate was much higher in a group that did not receive the vaccine, which is shown in the pink, compared to the group that had received the vaccine, which is shown in the blue. So up until the end of up until the 31st of October 2020, the protection conferred by the vaccine indicated that just 14 days after an individual had received a single dose, there was a 75% lower likelihood of people within a vaccinated group becoming infected with the virus. And the majority of these illnesses were mild and moderate cases of COVID-19. In fact, mainly mild cases of COVID-19. So until the end of October, the AstraZeneca vaccine in this instance was showing tremendous potential in terms of reducing even mild and moderate illness from the SARS-CoV-2 virus. But the unfortunate reality for viruses, bacteria, and most other organisms is that they do mutate. And the reasons why they mutate occasionally is that it occurs purely by accident, in that there's sort of a misread of the genetic material as the virus is replicating. But often the reason why viruses as well as bacteria mutate is that they're wanting to become more adept in terms of being able to infect the host. So as an example, the mutation that is prevalent in the virus in the United Kingdom, what is also referred to as a Kent variant as well, and that same mutation is shared in the South African variant or the B1351 variant. That particular mutation, which is known as a N501, allows the virus to become much more adaptable to infecting people. So it's got a greater affinity to be able to infect, and it also is able to be much more transmissible in doing so. But another reason why these viruses tend to mutate is that when they come under tremendous immunological pressure in the host, to be able to continue surviving and to evade that immune response of the host, they would undergo mutations. And unfortunately, in a country such as South Africa, where as many as 25 to 30% of adults probably were infected during the course of the first wave, what we find is that there was a lot of immune pressure built up against the virus, and consequently, the virus probably had to evolve to be able to evade that to continue its survival. And hence, we've got the evolution of viruses variants, not just in South Africa, but even in a place such as Brazil, where there was also high force of infection that have become evasive to the immune responses that were induced because of past infection. Now, this has got tremendous implications. It's got implications in terms of what we can expect when it comes to future resurgences from the virus, in terms of how long the virus will continue. And for all intents and purposes, the SARS-CoV-2 virus, well, COVID-19, is likely to be with us during the course of our lifetimes. It's unlikely a virus that is going to be eradicated anytime soon. In addition to the impact it might have on what is known as the epidemiology of the disease, it would also have an impact in terms of whether past infections confer protection against reinfection from a different variant. And then it obviously has got implications in terms of how well vaccines would work. As I mentioned, the majority of vaccines that are currently available are vaccines that have been designed primarily based on the original virus that was circulating. In addition to which, it might also have implications in terms of the diagnostics we use, as well as foremost in terms of our immediate concern, how this might affect the rollout of COVID-19 vaccines. So I'm not going to go into the detail. This is just to emphasize a point that the mutations that have occurred in South Africa, in addition to sharing a mutation that is evident in the variant that was circulating and still continues to circulate in the United Kingdom, unfortunately, includes additional mutations of other critical components of the genome that codes for important parts of the spike protein, against which vaccines usually produce antibody to be able to prevent infection or reduce the risk of developing disease from those particular viruses, from this virus. So as I had mentioned earlier, what ended up happening in South Africa is the evolution of the B1351 variant. Again, to emphasize, it started off in the Eastern Cape, but very rapidly spread across the rest of the country. And roughly about the second, third week of November, it probably became prevalent both in the Gauteng as well as in the Cape Metro. And the reason I'm pointing out these two regions is because all of our clinical sites where the study was being conducted were either in Johannesburg or Tshwane or in the Cape Metro. So until then, there was very little or almost none of this particular variant that was circulating. And subsequently, this variant, as you can see, became the dominant virus, the variant circulating in those areas where the study was being conducted. So this is what we experienced. Eventually, we were able to accrue 42 individuals that developed COVID-19 between the vaccine and the placebo group. And at that threshold, we were then able to do an analysis to determine whether or not this vaccine actually protects against COVID-19. We had not intended to be able to answer the question, which probably is of global importance, in terms of whether this vaccine would protect against a specific variant that has been recognized globally to be a major threat. Inadvertently, because of the timing of when we had enrolled participants into the study and when they were exposed to the virus most forcefully, what ended up happening is that 95% of all of the individuals that we were able to analyze in our primary objective of determining whether the vaccine protects against COVID-19 after 2 doses were a result of infection due to this B.1.351 variant. So inadvertently, the study now provides us an answer as to whether or not this vaccine, and probably indicates what the effect of other vaccines might or might not be in terms of protection, at least against mild or moderate illness due to this particular variant. So before doing that, what we did is we did some experiments in the laboratory, and these were courtesy of groups at WITS and NICD and ARI. And what they did is they tested the antibody that was being induced by this virus, by the vaccine, against the original virus that was circulating in South Africa. And then they tested the potency of that antibody in neutralizing the activity of the variant that's currently circulating. So we had same sorts of experiments in 2 different laboratories. And consistently in both of these laboratories, what they realized was that much of the antibody that was induced by the vaccine was not actually active against the variant that was currently circulating in South Africa, the B.1.351 variant. So we've seen a substantial drop-off in terms of the ability of the vaccine-induced antibody to neutralize the activity of this virus when tested in the laboratory. So obviously that would be reason enough to be concerned that the vaccine might not do what we actually set out for it to achieve on the first hand if these antibodies are not working that well in the laboratory. And that is really what has transpired. So unlike the earlier graph, which I showed you, where we had a 75% reduction of COVID-19 14 days after the first dose of the vaccine until the 31st of October, when we analyzed the individuals in terms of how well the vaccine worked against the variant predominantly, what we observed was very little difference in terms of the case accumulation between the vaccine group and the placebo group. And consequently, the bottom line in terms of these results is that there was a 22% difference, a 22% lower risk of developing COVID-19 in a vaccinated group, but that was not statistically significant. So we can't say, in fact, we can't say that we have not proven that this particular vaccine protects against COVID-19, and particularly against COVID-19, which is a consequence of infection by the B.1.351 variant. So that is largely disappointing news, but what I need to emphasize again at this point is that 2/3 of the COVID-19 cases in this particular study were due to mild infection, and the other 1/3 were due to moderate illness. So what this data don't tell us is whether or not this vaccine might still protect at least against severe COVID-19, especially individuals that are at high risk of developing severe disease. And I'll explain why I believe that might still be biologically plausible. Now, another important aspect, and these are data which were presented in a separate webinar about a week ago, and that was the Novavax vaccine trial. And one of the features in this particular Novavax vaccine trial to address the question as to whether past infection due to earlier virus that was circulating would protect against the current variant that's circulating in South Africa is we looked at groups of individuals in the Novavax trial that did not receive the vaccine. So those were the placebo recipients. And then we divided them into 2 groups. The one group were people that already showed that they had been infected with the virus at a time when they entered into the study. So we did a blood test to see that which proved that they were previously infected. And then the other group were people that didn't have past infection or evidence of past infection based on a blood test. Unfortunately, what we saw in this particular study of this longitudinal group group that were followed up longitudinally is there was absolutely no difference in terms of the attack rate, again, of mild or moderate COVID-19 based on whether or not a person had been previously infected with the original variants that were circulating in South Africa. So past infection by the earlier variants of SARS-CoV-2 that were circulating in South Africa, unfortunately, does not protect against mild and moderate COVID-19 due to the current variant dominating in South Africa. And that is important, and it probably also explains why the resurgence in South Africa, to a large extent, far exceeded the first wave, both in terms of number of cases, as well as the number of people that have died of COVID-19. What I also need to emphasize is that it's not all doom and gloom. Again, these are results that were reported about a week ago, and this is a Novavax study, Novavax vaccine, which is a different vaccine using a different sort of a formulation and technology. And these were results specifically from South Africa, where in a similar sort of demographic as what was enrolled in the AstraZeneca vaccine trial, relatively young individuals with a median age of about 35, 36. What we observed in the Novavax study was a 60% reduction against mild and moderate COVID-19 due to the B.1.351 variant. When including people with HIV in that analysis, that efficacy estimate drops to about 50% reduction, but there isn't much to be made between a 50 and 60% because of the uncertainty bounds of the estimates that surround that particular number. So yes, unfortunately, the AstraZeneca vaccine does not work against mild to moderate illness, but we do have vaccines that work against mild and moderate illness, including the variant that's circulating in South Africa. And for all the COVID vaccines that have currently been authorized, it shows a very similar sort of a trend, that vaccines that work against mild and moderate illness generally will have higher efficacy or a greater level of protection against more severe disease. So the question really arises, as you know, South Africa has now already received 1 million doses of the AstraZeneca vaccine, and might this vaccine still have some role to play, if not to protect against mild to moderate infection? And I think the data are fairly compelling that it will not protect against mild infection especially, but might there be reason to be optimistic that these vaccines might still be of some use in at least protecting against severe COVID-19? So Professor Glenda Gray will be providing a bit more detail on this. And again, these are data that were shared with the public in the past week, where we know that a single dose of the Johnson & Johnson vaccine, where South Africa was one of few participating countries in that particular trial, but specifically to the efficacy or the effectiveness of that vaccine that was observed in South Africa, what was noted was a 57% reduction in moderate to severe disease and an 89% reduction in terms of the risk of severe disease and death in South Africa. And the majority of these cases that would have occurred in South Africa, again, would have been due to the B.1.351 variant. So why do I believe that there's still reason to be somewhat optimistic that the AstraZeneca vaccine, which is likely to be the vaccine that's most readily available throughout the world, might still have some role to play, including in a country such as South Africa and other countries where the B.1.351 variant is likely to be circulating already, including our neighboring countries. And that is premised on looking at the relative immune responses that are induced by the Johnson & Johnson vaccine and the AstraZeneca vaccine. The Johnson & Johnson vaccine uses a very similar sort of a technology. It's also what is known as a non-replicating vector-based vaccine. So it uses a very similar sort of technology as the AstraZeneca vaccine. And when looking at the immune responses of these vaccines, after the first dose of vaccine, what I've highlighted in yellow indicates to you that in the same laboratory, the type of antibody that's being induced is very similar between these two vaccines. Now, most of you would have known, and I don't expect you to really look at the slide or make much of it, but the bottom line is that in addition to vaccines inducing antibody responses, they are also extremely important in terms of inducing what is known as T lymphocyte responses. And there is animal model data, experiments in animal, which indicates that in fact, T lymphocyte responses might be especially important in terms of protecting against severe disease. So with the AstraZeneca vaccine, it is known to be able to induce antibody responses to at least 87 different antigens of the spike protein. Of those, 76 out of those 87 antigens are not actually impacted by the B.1.351 site mutations. So for the majority of the T lymphocyte immune responses to the spike protein that is induced by the vaccine, we believe that those T cell responses will still remain intact, despite the mutations that exist in the B.1.351 variant. So in conclusion, I think at one stage we were highly optimistic, although the data weren't really available to me, that this vaccine might well protect based on the experience that was gained in the United Kingdom as well as in Brazil. And as I indicated to you, had the variant not evolved in South Africa, we would have been in a pretty good space. In that through to the 31st of October, we already observed more than a 75% reduction in mild and moderate illness that occurred at least 14 days after the first dose of the vaccine, at the time when the B1351 variant was not circulating. Unfortunately, we haven't subsequently been able to replicate those findings in that when looking at vaccine efficacy against this particular variant, we have not been able to determine that the vaccine actually protects against mild to moderate illness. But we do have a vaccine, as a reminder, that does work and protect against mild to moderate illness, including a vaccine that was evaluated in South Africa against the B1351 variant, and that is a Novavax subunit protein vaccine. Considering that the AstraZeneca vaccine and the Janssen COVID-19 vaccines have very comparable neutralizing antibody activity and use a similar sort of technology, and based on a Janssen vaccine showing an 89% efficacy against severe COVID-19, I believe that the scientists really need to engage as a community to try to decide how best to move forward with the vaccines that we've got available and the vaccine that is most likely to be most available and accessible throughout the world in the near future. So in conclusion, this particular SARS-CoV-2 variant that evolved in South Africa probably is a consequence of the immune pressure under which the virus was placed because of a high force of infection that took place the first time around. This is not unique to the SARS-CoV-2 virus. It's one of the reasons why we have to vaccinate annually against seasonal influenza, as an example. But at the same time, I think these results are very much of a reality check in that we've been somewhat euphoric of the early results that were reported for COVID-19 vaccines, when vaccine efficacy was being reported as being 95%. And all of that vaccine efficacy was not against the variant that circulates currently in South Africa and that has now dispersed throughout the world or into many other countries. So it is time, unfortunately, for us to recalibrate our expectations of COVID-19 vaccines, as well as how we go about deciding to respond to the COVID-19 pandemic, both in South Africa as well as globally. But that at the same time, we need to appreciate that COVID-19 vaccines really remain the only sustainable option for reducing the risk of severe disease and death. And it warrants ongoing urgent targeted approach in terms of its rollout, with a special focus on those individuals that are at high risk of developing severe disease and dying of COVID-19. And then on a slightly more optimistic note, for there's probably 2 or 3 vaccines that might well come into clinical trials in a period of the next 2 months, which either will be inclusive of the B1351 variant as well as the original variant, or at least adapt to be able to be more effective against the B1351 variant. So I thank you for the opportunity and your attention.
Thank you very much, Professor Madi. I do understand that the report you have to make had to be quite detailed, and that is because we have to combine this discussion with the release of the results. And all of this is coming out because we now have the whole community, the whole society has to having to debate the 2 issues at the same time. If there had been enough space, this could have been dealt with in isolation, but right now it's got to be dealt with in the context of what the next steps are going to have to be. But thank you very much for that. We're going to ask Professor Glenda Gray to come forward and give us
Good evening, Minister. Can you hear me?
Yes, we can hear you. Please proceed, and we can see your slides.
Okay. And you can see my slides. Great. Okay, so Honourable Minister, Honourable Deputy Minister, DG, DDG, MEC, all protocol observed. I'm going to present the findings of the Janssen Ad26 COVID-19 vaccine and what its implications are for South Africa. I'm talking on behalf of the MRC and the Ensemble study team. I too want to acknowledge all the participants who participated in the Ensemble study, as well as the 32 trial sites throughout South Africa, from rural to urban, from east to west, and from north to south. Your participation and your work on this trial has helped us greatly to understand the vaccine in South Africa. So I just want to acknowledge that. So I'm going to provide some just top line results for our Ensemble study. And that is the study, that is what we called our vaccine trial at a global level. So what is the J&J Janssen COVID-19 vaccine? Okay, what was the regimen? This was a single shot vaccination regimen. So only one dose of the vaccine was given in the study. The vaccine was an Ad26 platform, which contained elements of the SARS-CoV-2, and we called this the Ad26 SARS-CoV-2 vaccine. We've already used this Ad26 platform already, and we've used it extensively in Ebola, RSV, Zika, and some of the ongoing HIV vaccine trials in South Africa. Why is this Ad26 vaccine important? It's important because it's stable at 2 to 8 degrees Celsius, which is the normal normal fridge temperature in our country. We enrolled 44,325 people in the United States of America, Latin America, and South Africa. We had, importantly, lots of people over 60. A third of our participants were over 60, so we can answer the question about the elderly. 20% were over 65. 75, we had 3.5% of people over 75, and about 1% of participants were over 80 in our study. We had a nice distribution between male and female, and we enrolled about 15% of the trial in South Africa, and the rest were in the United States and Latin America. We saw good racial and ethnic representation, and we also enrolled people with lots of comorbidities, so we could answer the question how this vaccine works with people with comorbidities. Overall, we had about 41% of people who had comorbidities. The most were obese. Most of them had obesity or had diabetes or hypertension, and 2.8% of our participants had HIV, as well as other immunocompromised participants. This was important so we could get an understanding of how the vaccine worked in immunosuppressed people, including HIV-infected people. So I want to say first and foremost that this vaccine had an acceptable safety profile, and it's in line with all the other Ad26 vaccines that we've seen, and there was no particular safety signal observed. So that's very important. We always have to have safe vaccines. So I'm just going to give you a high level. I want to say that the Ensemble study, as I've mentioned, was conducted in multiple regions of the world. And it was at this time when the SARS-CoV, at the incidence where SARS-CoV-2 infection was very high, and it was at the time of our second wave, and in other parts of the world, their third wave. And it was at the time when new lineages of the virus were emerging. So what we found was that a single dose of the Ad26-CoV-2 vaccine was efficacious or showed efficacy in the prevention of moderate to severe or critical COVID-19 infection. And we had a vaccine efficacy of 67% on day 14 and 66% on day 28 post-vaccination. So already on day 14, we were seeing vaccine efficacy with a single shot of Ad26. And it's important to say that this was evident from day 14, and we saw increasing efficacy, increasing through day 56, especially against severe disease. In South Africa, it's important to say the vaccine was 57% effective, where nearly all of the cases were due to the new variant, the B1532, which, the B15135, which Shabir has been talking about. So I think it's very important that we saw that the vaccine efficacy increased with the severity of the COVID-19 vaccine disease. So we saw high vaccine efficacy, 85%, 28 days after the shot. And this was noted against severe and critical COVID-19. And the efficacy was observed as early as day 7, 1 week after the vaccination. And at day 14, 2 weeks after vaccination, it was 77% effective. So this high vaccine efficacy, you might say, well, what happened in South Africa, was consistent across all countries and all regions, and including in South Africa, where all the cases were due to the new variant, the B135 variant. And this is based on our sampling of available data, and about 95% of the data that we sampled has the B135 variant. So what are the next steps for this vaccine? Where are we going with it at a global level? So I need to tell you that J&J have applied for emergency use and have submitted a request for an EUA at the FDA last week. Already they are submitting applications for authorization to other regulators. And in South Africa, there is a rolling submission with SAHPRA. The submission started in December, and J&J regularly adds more data to the dossier so that SAHPRA can review this on a rolling in a rolling way. So how soon can we use this vaccine in South Africa? What are the next steps? So I want to tell you that we are in advanced discussions to further evaluate the investigational single-shot Johnson COVID-19 vaccine in South Africa in an accelerated fashion in the next few days. As the ensemble data has shown high efficacy against severe COVID-19, including this variant, especially with regard to hospitalization and death, over the next few days, we expect to announce a plan to expedite vaccinations using the Janssen investigational product in healthcare workers in South Africa. We are working with the National Vaccine Rollout Team, and our goal is to leverage the existing clinical trial infrastructure used for the ensemble study. So we know that the ensemble study demonstrated high efficacy in severe disease and death and hospitalization, even with our variant. And so what we are proposing to do is to do an expansion as a study, because we are waiting for the vaccine to be approved in South Africa. And doing the study rapidly in healthcare workers allows us not only to help healthcare workers prevent severe disease, death and hospitalization, but also to help us understand the vaccine as we roll it out in South Africa. So I just want to tell you, I want to show you the research sites and vaccination site interface. So we have the red line, the red arrows that you see, or the red little marks that you see, are an example in the Gauteng region of where the vaccination sites are for the government, and in the blue are some of our sites in Gauteng. And so you can see that we're very closely related to the vaccine rollout, and as far as our clinical research sites are concerned. And so we'll be working very closely with the research sites, with the vaccine rollout sites in the regions to help the healthcare workers access the A26 vaccine. Not only do we have vaccine research sites in Gauteng, we have research sites in Eastern Cape, in Mthatha and Port Elizabeth. We have research sites both in rural KwaZulu-Natal and in Durban, and we have sites in Mpumalanga and in Limpopo. And so we will be very able to work with our research sites and work with the National Rollout Program to roll out a phase 3B study to healthcare workers in South Africa. I want to acknowledge the many people that I've worked with in the last year and also in the last few days to try and realize this program in South Africa. And I want to first of all acknowledge Dr. Paul Stoffels and the J&J team who worked tirelessly with us to accelerate the provision of the A26 vaccine in South Africa, particularly to Abeda Williams, who's the local South African office, as well as the Minister of Health, Dr. Zweli Mkhize, Dr. Sandile, the Buthelezi, our DG, and also Ms. Claudina Lutz from the Department of Science Innovation, who has tirelessly worked with the teams to try and mobilize resources for the emerging work on the variants. I want to also acknowledge Zamir Bray, who's helped us with the logistics, Dr. Lawrence Corey, who is from the Fred Hutch Cancer Research Center, that has helped us with all the work we've done and enabling us to expand our work in South Africa, as well as Professor Slim Abdul Karim from Caprisa, who's also worked with us on this. I also have to acknowledge the study team who's going to be taking this work further, together with myself, Linda Gale Becker, Amina Goga, Nigel Garrett, Kaleka Milasani, Simba Takuva, Fatima Mayat, Jackie Odiambu, and Dr. Nonhlanhla Yendi. So thank you to all the team who will be working with the national rollout team to make sure that we are able to roll this out to healthcare workers in the next, quite rapidly in an expedited fashion. So thank you, Minister. I'm going to stop there and stop sharing my screen.
Thank you very much, Professor Glenda Gray. You have now heard about the J&J aspect of the trials. We're going to ask now Professor Berishuk to come in and make his comments on the issues relating to vaccination, but also in reflections on what we have seen just now. And thereafter, we're going to ask Professor Abdul Karim. Thank you very much, Professor Berishuk.
Thank you very much, Honorable Minister and Honorable Deputy Minister, Director General of Health, and all the distinguished guests. First of all, thank you very much for the introduction, and really thanks, a deep debt of gratitude and tribute to both our presenters, Professor Mahdi and Professor Gray. I think what we've seen tonight really kind of reflects the depth of science which we've got at our disposal. And it's really that depth of science, that incredible insight, the resources that we've got, that intellectual resource that we've got, which is reflected by tonight's presentations, which enabled us to pick up the variant, which is also important in guiding us where we go from here. And it's not only the trialists, and of course they've done a tremendous work. It's also the laboratory personnel throughout the country, and I'm not going to name them individually, but who contributed so much, both nationally as well as internationally. And we really do have world-class science in South Africa, and I think we're very fortunate in having so. And really the kind of issues which have been outlined tonight really center around the onset of the variant, of the 501Y2 variant, or as Professor Mahdi called it, the B351 variant. It's really this which has imposed the issues and the challenges which we now have to deal with. And it's really the information which has come forth is really what's going to be so important in where we go from here. So we need to kind of now assess, what do we want? What do we want really from a vaccine? And we can really look at it from a couple of levels. Clearly, the kind of prime aim, the prime goal of what we want from a vaccine is to prevent severe disease, hospitalizations, obviously mortality, the overburdening of the hospitals, overburdening of the healthcare workers in the hospitals. That must be our prime game. And so really the prime aim of the vaccines is to prevent severe disease. And we've seen Professor Gray pointed out the 88% reduction of severe disease with the Johnson & Johnson vaccine. We don't yet have data on, but we can extrapolate, as Professor Mahdi said, efficacy against severe disease from the AstraZeneca vaccine as well. Moderate disease, do we want to present moderate disease? Yes, we do, because moderate disease, of course, has an impact on the economy. It has an impact on the health of the country. Mild disease, well, it depends how mild. We do tolerate very mild infection. We do tolerate infection from the cousins of SARS-CoV virus to the endemic coronavirus, which cause our common cold. We never bothered about addressing that at all. And if we can reduce the level of disease that SARS-CoV virus, CoV-2, cause in the country to what the other coronaviruses cause, obviously that will be a tremendous win. And then lastly, do we want to prevent asymptomatic infection? People that get infected but don't have symptoms, don't have any clinical disease. And that obviously has a bearing in the onward transmission, the ongoing transmission of the virus in the community. So I think these are all the considerations which we're going to look at as a Ministerial Advisory Committee on Vaccines as we go forward, and guided by the science which the scientists have so very ably provided to us. So I guess our immediate challenge, our immediate issue is where we go from here in the very short term. The AstraZeneca vaccine, Professor Mahdi did present some rather disappointing initial studies. But as he pointed out, there may well still be utilization, effective utilization of AstraZeneca vaccine. For example, we need to look at the cell-mediated immune responses. We may need to look at combination of AZ vaccine with other vaccines, which may in fact give synergistically a very good response. So I think we just need to maybe suspend use of AstraZeneca, but investigate it more fully to see, can we utilize it more effectively? And then obviously there's very optimistic news which Professor Glenda Gray presented to us with regard to the Johnson & Johnson vaccine. And also maybe other vaccines. So I think this scientific guidance is really so important as we evaluate all the various aspects. We will be having an in-depth discussion tomorrow evening with both international as well as our local national expertise to kind of help guide us in providing a rational answer, a scientifically based, evidence-based answer going forward. So thank you, Minister. Thank you very much for arranging this. I think this has been extremely interesting and extremely useful. Thank you very much, Minister.
Thank you very much, Professor Berishuk. I think your reflections will be very important as we take the next few steps forward. At this point, let's invite Professor Abdul Karim. If you can just come in at this point, and we will then, after your presentation, we will then quickly open for questions. Thank you.
Thank you very much, Minister. I'll just say that all protocol observed. I'd like to start by thanking both my scientific colleagues for their excellent presentations. I think it's a good signal of the importance of doing research in South Africa and the way in which it contributes to our understanding of what's going on. I'm going to follow up on Professor Schub's presentation, and I'm going to address the key question, which is, when we look at all of the vaccines in relation to the variant that we have circulating in South Africa, the 501YV2 variant, how does South Africa move forward with vaccine implementation in that context? So I will address that by just very quickly reminding us about the epidemic and where we are, but then going directly into how to assess whether a vaccine is effective, and then what do we know about vaccine efficacy and the variant, and make some conclusions. So in the next 10, 15 minutes, I would just try and capture this in a much more broader context. So by way of just a reminder about where we are, I mean, we are now very close to the end of the second wave. Our numbers have come down quite substantially. We are still hovering around the 4,000 odd mark. And if we look at the way in which the second wave grew, it's a reflection of just the sheer burden of clinical illness, the hospitalizations and the clinical and the severe disease that leads to death. And so that's a very important part of what we need to deal with in this epidemic. And we look at it from a provincial point of view across the provinces. From barely 3 weeks ago, we were looking at a situation where across the board, our country was in the red color. We are now doing quite well in the way in which the numbers have come down across the board. So how to assess whether a COVID-19 vaccine is effective? I'll talk about the credible source of information, the number in the trial. I want to look at the two different kinds of disease. So just by way of pointing out, that we have published information on only 4 of the 7 vaccine trials where we know their outcome. There are 1 or 2 more trials that have sort of released bits and pieces of information, but these 7 trials have released, at least through press releases or published papers, information about their vaccine. So I will draw on this information. And of course, published information carries a lot more weight than a press release for obvious reasons. So if we look at the first question, do vaccines prevent clinically apparent SARS-CoV-2 infections that are circulating from the pre-existing variants? In other words, the variants besides the 501YV2. And the answer to that is yes, quite well. across the board. If we look at any of the vaccine, these 5 vaccine trials that have published their efficacy, we can see that clinically apparent, that's the full spectrum of any clinical illness, they do quite well. From the largest study, that was the Johnson & Johnson study, to the smallest study, which was the AstraZeneca, we of course will put much more weight on a big study than we would on a small study. For obvious reasons, the numbers are different and the weight we give it, therefore, will be higher. So the first thing we know is that these vaccines work well against the pre-existing variants. And the reason they work well is they were developed using the pre-existing variants. So do they work well against severe disease and hospitalization? So the answer there is yes, pretty well. The Johnson & Johnson, as you heard from Professor Gray, 85% effective against severe COVID-19. Pfizer shows 90% effectiveness against severe COVID. Moderna had 30 cases of severe disease in the placebo arm with 0 in the vaccinated arm. The same with hospitalization for Moderna, and so too with Gamaleya. And even AstraZeneca, even though the numbers were small for severe disease, for hospitalized disease, did very well. There were only 2 cases of hospitalization, and those were early after vaccination. In fact, if you look at AstraZeneca, at 2 weeks after the second dose, they had 0 hospitalizations in the AstraZeneca trial and 15 in the placebo arm. So there's no question across the board, these vaccines work really well in preventing severe disease and preventing hospitalization. But that's with the existing variants. They were designed for the existing variants. So let's go on to answer the question about what do we know now about vaccine efficacy and the 501YV2 variant. So we know that they work well against the pre-existing variants. What about the new variant? Well, we look at 3 levels of evidence. We look at laboratory assays, and there are 2 different kinds of assays. I won't bore you with the details. We look at clinical efficacy against mild and moderate infections. And then we look at clinical efficacy against severe infections and hospitalizations. Now, we would regard hospital lab assays as of interest, but clinical data, we would consider that really important. But if it's only of mild disease, we consider that a modest level of evidence. What we really want to know, does it prevent severe disease and hospitalizations? Because that's what we're trying to avoid. So let's look at the available evidence based on these 3 things. So I'll go through each of the vaccines quickly, and I have a summary slide that just captures it all. I won't present all the detail of each of these papers. I provided the papers so you can go and look at it yourself. But both the Pfizer and Moderna have shown that in vaccinees who received these vaccines, that in the lab assay, they seem to do reasonably well in killing the 501YV2 variant, even though the neutralizing activity is diminished. And it's diminished for Pfizer between 1 and 3-fold, and for Moderna up to about 6.4-fold. So there's a substantial decrease. In other words, we need more antibodies in order to be able to kill these, to kill the 501Y2 variant, the V2 variant. So we are seeing a diminished neutralization, diminished killing capability in the bloods of patients who are people who receive Pfizer and Moderna vaccine, but not to the extent that it looks like it's compromising these vaccines' ability to kill the virus. But remember, we have no clinical efficacy evidence against the 501YV2 variant. These are just laboratory studies. Similarly, for whole kill vaccines for Sinopharm, their assessment shows that they use a live virus lab assay, and they show a small reduction, 1.6-fold, against the 501YV2 variant. Again, no clinical efficacy evidence against the variant we have in South Africa. Novavax, the protein subunit vaccine, well, this provided us now with real clinical efficacy information. However, the numbers are not fully available yet, so we can't assess it in fine detail. It's only in a press release. And of course, we've seen the headlines across the world that the evidence showed that this vaccine is 89% effective in the UK, but only 49% effective in South Africa. So the answer to that question is, are protein subunit vaccines effective against the variant? Well, partially. The Novavax vaccine's clinical efficacy raises quite a lot of concern because of such a drastic drop in efficacy. What about the viral vector vaccines? Well, there are 3 viral vector vaccines, and I've just provided you with the information, and you've actually heard about the AstraZeneca data that overall efficacy for all of the countries combined was 67%, as we saw in the preprint that went up last Thursday. However, when we look at the South African data on its own, it's concerning that it's down to 22%. So now we're seeing that with Novavax, and we're seeing that also with AstraZeneca, that against the South African, against the 501YV2 variant in South Africa, we're showing diminished clinical efficacy. Fortunately, we heard from Professor Gray some good news, that the Johnson & Johnson vaccine with a single dose, not even a double dose, just a single dose, shows a smaller decline in efficacy compared to the US or compared to Latin America. So that's the overall evidence. I can summarize it for you in this graph, that if you look at the laboratory assays, that's the evidence we have. I won't go through it because I've already touched on it when I went through each of the vaccines. And if you look at the data overall, this is what you see. I put smiley faces for where I think you would be pleased to see those results. And I put some not so smiley faces in the other places, and some non-committal faces when we're not sure about what exactly it would mean. So when we look at the evidence that we're seeing, we really want to know about clinical efficacy. This is what we want to know. This is the table we want to know. And in particular, we want to know about the last column. Without evidence in the last column, we're not sure if the vaccine against the 501YV2 variant is effective in preventing hospitalizations and severe infections. And at this point, as you can see, we have that data for Johnson & Johnson. We do not have it for any of the other vaccines. So what have we learned about vaccines and the variant? Well, firstly, laboratory studies show that all vaccine-induced antibodies have greater difficulty neutralizing 501YV2. That's across the board. The variant compared to the existing variants, we saw with Pfizer and Sinopharm that the decline in neutralization was small. With AstraZeneca, we saw that it was substantial. The clinical studies for moderate and mild disease, we saw declines in efficacy. AstraZeneca showed that, Novavax showed that, J&J showed that to a limited extent. No data on Pfizer, Moderna, Gamaleya, and Sinopharm. If we look at clinical studies on severe disease and hospitalization, which is likely to use both antibodies and T cells, there we see J&J has high efficacy at 85%. But we don't have data for this on the other vaccines. And so clinical data on severe disease and hospitalization are essential. And we need to do large, simple rollout implementation studies in South Africa to get that information. So how do we think about the next steps? What's the way forward? Well, we show that we've seen that COVID-19 vaccines from existing variants are very effective against the existing variant. And so we need to wait. And at some point, we will see in the near future, and we expect this pretty soon, that the next set of vaccines will be made from the 501YV2 variant. And so they're likely to also be effective against the 501YV2. We're expecting 2 kinds of new vaccines. The first are 501YV2 boosters, and we already heard from at least 3 of our colleagues about the good progress that they are making on these boosters. And this would be a booster. So you would take the existing vaccine to give you immunity against the pre-existing variants, and you take this booster, which would boost it in order to give you protection against the 501YV2 variant. We're also going to see a next generation of vaccines that are intended to actually be much broader. So they will cover you not only against all the current variants, but also what are likely to be future variants. And that we're going to see emerging over time. That will take a little longer. The AstraZeneca and the Novavax trials in South Africa have shown that clinical efficacy is diminished substantially, but we don't really know the answer on severe disease. So we need that information on hospitalization, and we can't make decisions without that. And so the AstraZeneca trial, the AstraZeneca vaccine rollout, needs to be put on temporary hold while we get the clinical efficacy information. And the way we can do that is through the new approach to rollout, which Professor Gray outlined so well, that with every vaccine that we are now going to roll out, we can think about it as a two-step process. It's a stepped introduction of each vaccine. The first step is to roll it out to a fairly large number of people in order to assess what the hospitalization rates are. And we can do that because we have a system in place that monitors all admissions. We would need to collect vaccination status in that database in order to collect this information quite quickly. And as we make progress with the rollout in step one, if the hospitalization rates are acceptable, we then continue and move on to step two, which is the wide-scale rollout. If the vaccine shows to not be effective in reducing hospitalizations, then we would need to offer those individuals another effective vaccine, either a booster of that vaccine with the 501YV2 booster, or to give them another vaccine. So we can still proceed with our rollout, but we need to do it wisely. And we can do it wisely by taking a stepped approach. And we can do that, and we're already starting to think of how to do that with the J&J study that you just heard from Professor Gray. So while we heard some not so good news, we've also heard from Professor Mahdi's study, we also heard some good news from Professor Gray's study. And with all of that information, we understand the importance of getting clinical data on hospitalization and on severe disease. And we can do that as part of the rollout so that it's like a rolling activity. And we use the first part of it to assess the data to make the decision for the continued rollout. On that note, Minister, I'd like to end by just reminding people that we have very clear criteria by which we include vaccines in our vaccination program. No vaccine that does not meet these high requirements will get into that program. And even if it's part of a study, we can assure people that it's met these criteria. Thank you very much.
Thank you very much, Professor Abdul Karim. Let me then say I will give the last final comments, and then we're going to entertain the questions. I have had a number of people sending me the message to say the science is too deep. I want to apologize for that, but I also want to say that in reality, what we are dealing with here, we had to combine all of this because we have been under pressure. To make sure that the public is well updated on a number of issues. At this point, we felt it was important that once the matter is out there and being discussed, we won't always be giving you all the details, scientific analysis of this nature. However, this one being the first of those public releases of these results, it had to take us that way. So I've asked myself 6 questions, which I think anyone out there might want to know, what is it that this means to all of us? The first question is, what are the implications of this report on AstraZeneca? Let me just take you through briefly so that we share the understanding. And what the trial has found is that it was conducted, this AstraZeneca trial was conducted in the South African epidemic when the wild type virus was dominant, and the results of the trial revealed that the vaccine was effective. Those results were the same as what was seen in the UK and in Brazil. Subsequently, the virus in South Africa mutated to develop a variant which alters the spike protein of the virus. The virus has also been assessed against, the vaccine rather, has been assessed against this variant for effectiveness. The results suggest that the variant has significantly reduced the effectiveness of the virus on mild or moderate infection, and we are uncertain about the impact of the vaccine that it will have on hospitalization, severe diseases, and death. Excuse me. This means that what we will take from Professor Shabir Madhi is that some more work needs to be done on this issue, because the results from other countries have been quite satisfactory, but there are issues in South Africa that we need to study a bit more. So that's the first question. The second question is that linked to that is that the J&J study has been quite satisfactory, as we have heard, on mild, moderate, severe disease and hospitalization and reduction of death. So the next question is, why did we then get AstraZeneca vaccine? The answer is very simple. You know, when we were dealing with the issue of vaccine acquisition, the first question we asked, why didn't we bid on all of these vaccines? And we said, no, the results were not known. So we had a difficulty in putting any bid when we didn't have the results. Right now, as we're coming to this, the results were not out, but there were already indications of which vaccines were actually highly considered. And amongst them, AstraZeneca was that. In the process, we then went for availability. Which of these vaccines could be accessed as early as possible? You recall that when the president went in public, the president announced that the COVAX facility will deliver the vaccines as early as April. And we then subsequently indicated that the president's announcement is correct insofar as the COVAX facility was concerned. But the president had also said we must try and make sure we make these vaccines available much earlier than that date. And we did say in public that we are targeting a release of these vaccines in February. And we were even trying to get them as early as January. When we ultimately got AstraZeneca at the time with the results promising everywhere, but these results from this trial had not been concluded. They only just came out this week, which therefore means that the reason why you hear the point is disappointing is because we're ready to roll, but nevertheless, we think that we need to then look at a bit more work so that therefore, what do we do with the people? Then what we will then do is we have to get our team. I've directed that our scientists must quickly sit together and figure out what approach are we going to use in order to effectively deploy the AstraZeneca vaccines. It must be clear when that can be done, what conditions need to be fulfilled, what do we need to do about all of that? So that basically is the assignment that has been given to our scientists as they're all together here. They'll figure it out. They'll come back to us and say, this is the proposal on the AstraZeneca. So it's a temporary issue that we have to hold on to AstraZeneca. It is temporary until we figure out these issues. What are the next steps supposed to be? When we know those steps, then of course we bring it back. The fourth question is, then what does it mean about our vaccination program that we said will start in February? Well, the answer is it will proceed. It will proceed as we have learned. Professor Abdul Karim has just said, we have learned that when we implement, this is something that only arises when we look at all of these results now, which were not available before. Now the approach is that we will do the implementation of the vaccine program, but we will link it with an implementation study, which in other words, it means we're going to then have to align our research bodies together with the vaccine rollout network that we had already created. Between the two, there will therefore be a platform to roll out the vaccination program. And initially, it will be led by implementation study approach. And then as we move on, it's going to be focusing on the opening up to more and more people once those numbers that are needed in the study are fulfilled. That process is fairly advanced. We have had a discussion, if you have heard Professor Glenda Gray talking about it, we have actually been involved in a whole discussion. When we realized, excuse me, when we realized that there's going to have to be a need of tweaking our strategy, we then started involving, discussing how all of these processes will be in synergy as we actually implement. So we still expect that we will continue with our vaccination program, but it will now be superimposed with the implementation studies. There are a number of implications that are associated with that, because obviously there are protocols involved. There's registration for registration for the study. All of that we're taking care of, and we hopefully will be able to give you proper announcements tomorrow in the next few days. Then the fifth question is that which vaccines will we be having in our situation, in our armory in the next 4 weeks or so? Between now, let's say from next week to 4 weeks time, we will have the following vaccines. AstraZeneca is still here with us. Then we'll also have some from J&J. We'll also have some from Pfizer. I will not give details because there's quite a lot of discussion and negotiation that we're finalizing, but we can just say we will be able to move on with all of that. In other words, available for the health workers will also be the J&J and the Pfizer vaccines as we move forward. Then the next question is about future. Well, in the future, we will obviously have got somewhere along the line, we will get the response about what to do with the AstraZeneca, and therefore at the right scientists, then we will have increasing numbers of vaccines that will be coming from the two, which is Pfizer and J&J. We are also still in negotiations with a whole number of other vaccines. There are discussions going on Sputnik V. There are discussions going on the Sinopharm. The department and the Ministerial Advisory Committee are dealing with that. There are discussions that are going on with Moderna, and we will also need to explore on Novavax, because that one had not been much of discussion. So the discussion on all of them remains open, and we will continue with those. So all in all, I think that all we wanted to do is that when you read all of these issues in the media, do understand that this is a very dynamic platform that we're at in terms of the research and new findings and so on, and different situations in different countries. But nevertheless, in terms of where we said we are going, we will be continuing with our program. This time it will have been tweaked with an integration of the vaccination platform over with the implementation studies that will be done at the same time. That is back office work that will be done by our own teams, because all our research teams and our health national vaccination program, all of those are people who are working together as one team. Research are also going to be out there doing different, looking at different questions and come back with the answers. At the end, all the answers that they'll get from research are coming back to us so that we are able to refine our health, public health policy approach. So that is the situation that we are at. It will remain like this for quite a while because there'll be new information, new decisions, and so on. But at each and every time, we shall continue to update the public. May I hand you back now to Dr. Lwazi Manzi to be able to deal with the questions that are coming. And of course, those who want to ask more questions to the scientists, you are free to do so. And at this point, if we are not able to complete all the questions, they'll still have to ask the scientists, particularly from journalists, to be able to get their responses at a later stage. But thank you very much to all of you. And I do understand that this must have been a little bit long and intensive, but it won't happen like this all the time. We will always make sure we give you fresh information. At this point, we want to thank all our scientists and thank all the researchers for the exciting information that they've brought to the fore. And we're going to move on from there. Thank you. Hand over to Dr. Manzi. Please take your questions. Thank you.
Thank you very much, Minister. Now, I did indicate, Minister, to the broadcasters that we would really try to wrap by 9 o'clock. So I think we have 20 minutes to be able to ask questions, and we'll prioritize the media now. And so the first question is for the Honorable Minister from Sophie Mokoena. The Minister spoke about cutting-edge research capabilities as part of the task team that was appointed by President Ramaphosa during his tenure as chair of the AU. What is the continent doing to build vaccine manufacturing capacity? The COVID-19 has demonstrated that the global South can't always depend on the global North. The next question comes from Christian Duplessis from Network24. His first question is, are we still going to use the AstraZeneca vaccine on healthcare workers considering the new data? And the second question is, should we not rather wait for adapted vaccines for the variants to become available? So either Professor Madi or Professor Gray can take that one. From Nadia Honeyball, have you started or will you be starting soon with trials to see how effective the AstraZeneca vaccine is against severe cases of COVID-19 caused by the new SA variant? And she goes on to ask, if the vaccine is used now to vaccinate health workers, will you be vaccinating those workers again when more effective vaccines are secured? And I think there's quite a number of questions that have actually come through. And so I might as well just wrap them into one question where there are participants and members of the media asking if, in fact, it will be possible to give a different vaccine after you have given the AstraZeneca vaccine. And I think even on the next level then would be to answer, is it possible to use two different vaccines as a regimen together? The next question from Christian Duplessis again. What does the new data mean for the spread of the virus and achieving herd immunity? Professor Gray, I think earlier we did have a discussion about this. I think it's an important question. And then Nathan Geffen from Ground Up has asked, the Daily Maverick reported today that the AstraZeneca vaccines are expiring in April. Firstly, they wanted to know if this is true, and if it is correct, isn't it an unusually short expiry period for vaccines just received? And the third question is, if the AZAC vaccine is still going to be rolled out, is it possible to use all the doses before expiry? And if not, is it still feasible to continue administering the second doses of the vaccines after the expiry date? And perhaps Dr. Anbanpile may also weigh in on this question. I think, let me ask the last question from this lot. Again, Sophie Mokoena, vaccine nationalism is a big challenge. South Africa participated in the Johnson & Johnson trials. Will the vaccine be available to South Africa? And how are you going to deal with mutation of this virus in future? I will hold it there, and I think if we can start with the Honourable Minister.
Thank you very much. Let me make the responses brief. There is a huge discussion in relation to the creation of a manufacturing capacity in the continent. It's been raised by President Ramaphosa. It's been raised by a number of other heads of state. So there's a focus on that. In the interministerial committee that the president has appointed, there is a stream, work stream that is being led by Minister for Higher Education, Science and Technology and Innovation to look into that area of capacity of manufacturing in South Africa. There's already been a number of countries that have been conducted to discuss this particular issue. So it's certainly firmly on the table. Secondly, which vaccines will be used as we move on as of next week? I had answered the question actually. I have indicated that from next week, for the next 4 weeks, we expect that there will be J&J vaccines, there will be Pfizer vaccines. So what will be available to the health workers will be those vaccines. And I have indicated that the AstraZeneca vaccine will remain with us as long up until the scientists give us a clear indication as to what we need to do, how we need to utilize it, and so on. That team has been assigned by myself to look into that aspect. They must also look into the issues of expiry. What should we do and how quickly can we deal with it? And as to all of those questions, once the team has looked into all of that. So to ensure that there should be no wastage procured, we will get the answers as soon as they proceed with the other questions. Thank you.
So Lwazi, I can answer the question about what some of the things that from the minister. Just to say that we know, someone asked, should we wait? So I want to reiterate that the J&J 826 vaccine protects against severe disease and hospitalization and death with the current variant. And so we have data from South Africa to show that we can use this vaccine to protect against death and hospitalization. And we are looking at further data about how this vaccine impacts on mild disease. So this is a vaccine that is a silver bullet. Yes, it won't protect against the sniffles, but it'll protect against death and hospitalization. And so, as the minister has said, this is one of the vaccines that we will roll out and we will evaluate, and we will evaluate in the field. And the first instance is to evaluate this and roll it out into healthcare workers. So I think we can't wait. We have data, local data now, and so it would be not good to wait for future vaccines. We have to start with the data that we have, and we have good data from the Ad26 J&J vaccine.
Thank you very much, Professor Gray. I just want to check if Prof. Madi would like to weigh in on any of these things.
So thank you, Lwazi. So I think there are two issues that I would like to pick up on. The first issue relates to interchangeability of vaccines. And those sort of studies are already underway in the United Kingdom, where some individuals that received the AstraZeneca vaccine will probably be receiving the Pfizer vaccine as a second dose. And probably within the space of the next 6 weeks or so, we should get some data with regard to the interchangeability of vaccines. And it might well be that in South Africa, that we also explore the interchangeability of vaccines, including possibly the J&J and AstraZeneca vaccine. The other important issue, which I think I would like to bring to the fore, is that it's very likely South Africa, unfortunately, will experience another resurgence in next, probably in 3-4 months when we head into the winter period. And the question that we need to ask ourselves, in the context of knowing that the COVID-19 vaccines, in both the AstraZeneca as well as the J&J vaccine, are safe, foremost that they are safe. And even though there are question marks in terms of the effectiveness of the AstraZeneca vaccine against severe disease, do we want to take the risk of not vaccinating high-risk groups now, knowing that we're not going to cause harm, but that they might be protected against severe disease? So I think it's an important question that we need to address. And I think it somewhat would be reckless for us to decide just to discard of the 1 million doses of AstraZeneca vaccine that is available, with a biological probability that those vaccines might still be useful in terms of protecting against severe disease. So we might want to reframe our target group for vaccination in the next few weeks, few months, but it really needs to be focused, centered around the prevention of severe disease and death from what will likely be a resurgence sometime soon.
very much, Professor Madi, for those very important points. I just want to check if Prof. Slim would like to say anything. Prof. Abdul Karim?
Yes, thank you very much. I think many of the points are covered. I'll just add to Professor Madi's important point, is that as we see multiple vaccines come out into the field, we're likely to see different responses. And the UK study that's looking at a mix and match of various vaccines will give us quite important clues. But given that we already are vaccinating people with past immunity, so in other words, those who've had existing immunity, I think that's a good signal, because those individuals, when given a single dose, for example, of an mRNA vaccine, have a massive boosting response. So I think it bodes well, but we need the actual empiric evidence to just assess the safety of giving the 2 doses and then the immunogenicity. And those are not clinical long-term studies. They can be done quite quickly and within a short period of time to answer that question. That if somebody took this vaccine, it didn't work, can they take another vaccine? Is it safe? And those answers are coming pretty quickly, and they should. I'm pretty optimistic that it'll be a positive response.
Thank you very much, Prof. Abdul Karim. Professor Shu?
No, thanks to it. I don't think I can really add very much. I think everything has been said. Thank you.
Okay,
I think
thank you, Professor Shu. Now, if I may ask Dr. Anban Pillay, just if Dr. Pillay, if you could just answer the question about the expiry date, if you wouldn't mind. Thank you.
Thank you. Thanks for the question. Good evening, everyone. Look, the expiry date on the vaccines ordinarily are 6 months. These vaccines just have a 6-month expiry date. Unfortunately, these vaccines came through with an expiry date in April, which we only identified upon arrival. So we've engaged Serum Institute for an extension on the date, if that's possible, or an exchange of the stock so that we can have vaccines with a longer expiry. So we're just waiting for their response around that. Thank you.
Thank you very much, Dr. Pillay. I think I'm going to move to the next set of questions, and I think they may need to be the last set. So I will try and pick some questions that are sort of commonly asked questions across the board. So I have a question. I think if Minister can maybe tackle this one from Tamar Khan, who basically asks if we can give back the doses to the Serum Institute of India. And then we also have a question from Nadia Hannibal, and this will also be for the Minister. Will this new information about the efficacy of the AstraZeneca vaccine affect government's approach to lowering lockdown levels? That is, will government err on the side of caution with regulations? And then I think Professor Gray, there is a doctor here who's asked, in terms of the vaccine rollout being used in a sort of trial or study format, are healthcare workers not being used as guinea pigs? Would you please respond to that? So may I ask the Honorable Minister to come through? Minister, we were struggling to hear the Minister earlier. I hope the connection is better.
Okay, you will indicate if there's any problem. I couldn't detect it from my side. Actually, I picked up that question from the platform about people being used as guinea pigs. Actually not. The truth of the matter is that the J&J vaccine has been proven to be fairly effective, as you will have seen from the proven so, and it's actually being used in other countries already. So we're saying that in the next few weeks, those are going to be the ones that we'll start on with. And in the process, we are actually doing an extra step, which is the implementation study. It's not the same as the original study where you give some people placebo and then you give them the vaccine. Here, everyone is now being vaccinated. All we're asking is, having vaccinated them, let's just keep a monitor what happens as we move on. It is not because we don't know what the efficacy was, which has already been proven. It is not because we have got a question about the safety. It's a question of saying now, we're now implementing what does it do? What do we need to change in the future in the way we go about it? But Professor Gray can go into that, but it's certainly not being guinea pigs. Once you get a vaccine, you're vaccinated. It's not like we're trying, it's not a trial and error. Once you get vaccinated, you've got the vaccine. And therefore it starts the work of creating immunogenicity. And that we will continue with the same vaccines later, even if we have stopped this issue, the implementation study, we'll still continue with the same vaccine. So there's no one who's a guinea pig. It's actually an additional way, and that Professor Abdul Karim said, smart way of implementing. So it's implementation, but in addition, we have also to do a study, and we've done that because we are seeing that there are interesting findings to get. Then, in fact, one of the other people, this one came from Dr. Kumede, but there's someone else there who I think his name is Mubaiwa, who was saying this is an agile, sustainable vaccination strategy. That's what it is actually. What we have done, we've basically pulled everything that we've got, which is to our advantage, and we're pulling it together so that as we move on, we're able to vaccinate as we check also what else needs to be done as we go on with the implementation. We're not actually trying to find that. The question is now, it's now in reality as we go about this issue. And Dr. Ngiti then made a comment that SAPRA, the ball is in your court. True, it's in SAPRA's court, but in fact, we have been discussing, and SAPRA has actually risen to the fore, because on the AstraZeneca, they've actually issued that, and then they is in a position to also respond without compromising the quality of the work that they have to do. So from that point, we're dealing with it. So whilst it is an implementation, we also will be doing a study on it up to a certain number of people who are vaccinated. After that, we will just continue because the vaccination process will be continuing. But the
I think we've lost the minister again. Minister, we are once again struggling to get through to you. So let's ask Professor Gray to take over at this point.
So I mean, I'm happy to say that this is no experiment and this is no guinea pig. A single shot of the Ad26 vaccine will stop hospitalization and death. And we intend to...
We'll need a certain number of people.
Well, apologies for that. I think Minister just has a signal problem. Please go ahead, Professor Gray.
Okay, so thank you. So I agree with the Minister in that this is healthcare workers are not guinea pigs, and this is not an experiment. We know that we know from our study that the Ad26 vaccine starts from day 14 and 28 days after vaccination will protect against hospitalization and severe disease and death. And so we want to protect our healthcare workers. We want to give them the vaccine, and we want them to be protected from severe COVID disease, from hospitalization and death. And so the quickest way we can bring this vaccine to healthcare workers is in this program. And people will get the active vaccination. As the Minister said, there is no placebo. And the reason why this has been done in a study is because we want to understand better if there are any breakthrough infections, how we can see what impact the vaccine is having on viral escape. So it's very important for us to do this, and for us to make sure that our healthcare workers are protected before the third wave. And so this is no experimentation. This is no guinea pigs. This is active vaccination to protect our healthcare workers from death and hospitalization.
Thank you very much, Minister. I think we have you back. Apologies that we probably interrupted you while you were talking, but we could not hear you. Would you like to finish your thoughts, Minister?
Yes, thank you. There are just two quick questions. The issue of the AstraZeneca, the first thing we want is our scientists must tell us what do we do with AstraZeneca and how quickly can we bring it back to stream. That is what will guide what else we do about it. So there's no plan to send it back as we speak. The plan is to find out from scientists how to deal with it going forward. Then the question about changing the plan on lockdown. Look, the vaccines are supposed to help us to reduce the number of people who are severely affected by the infection. Now, in the case of the lockdown basically becomes a response to a raging infection. And we have really avoided to go to the kind of lockdown that we had at the beginning. Every now and again, we might need to intervene, but we believe that we have learned enough that South Africans will be very cooperative and supportive, that they will use the masks and distancing and hand washing and sanitizers so that we can delay as much as possible the emergence of the third surge. And in this case, we want to say it's all in the hands of South Africans. Even if we're to vaccinate as many people as we can during this year, we'll still need to keep the use of masks, the sanitizers, distancing for as long as possible until we are able to conclude that the risk of this infection is abated, then we will be over. So that is what will determine how we respond, is the way we the flare of the infection. If the infection is kept low because we are using masks and sanitary restrictions. Thank you very much.
Thank you very much, Minister. It is 9 o'clock, Minister. I'll take guidance from you, but I think we're going to be bidding our broadcasters farewell. If the Minister would like to continue, we may, or otherwise we may actually close the press briefing. We have actually exhausted the questions from the media, and the rest of the questions are in the Q&A. There's 99 plus questions now, and I see that our panelists have been answering some of the questions, and we thank you for that. And so I think that perhaps, Minister, we could potentially bring the briefing to a close. And of course, we will always be available as communicators to answer anything. However,
well, thank you very much. Thank you very much. I think at this point, we should say thank you to all our viewers, all South Africans. Thanks to all the media and the broadcast services. Thanks to the researchers and the panel of our experts. And thanks to all of those members of the media and members of the public that have had interest and asked questions and participated. And thanks to the members of the department. We will again update each other. In the next few days, we'll also be continuing to share more insight into these issues, and our experts will be available. But at this point, I'd like to say thank you very much for all the work that the team has done, and thanks for giving us the time and your attention. We would like to close this session at this point. Good night. Bye-bye.
Thank you very much, Minister, and thank you to all the esteemed panelists, and a very good evening to everybody.
Bye. Thanks.
Bye-bye.
Thanks very much. Bye-bye.